I have a dataset with 5 features, which I'll call A, B, C, D, and E. The goal is to predict a binary outcome, meaning there are only 2 possible results, like yes, no, or success, failure. I'm using a tool from Sklearn, a popular Python library for machine learning, called mutual_info_classif . This tool helps me figure out how strongly each feature is related to the outcome. A higher score means a stronger relationship. I get a score for each feature. For example, feature A has a score of 0.15, feature B has a score of 0.02, and so on. Higher scores mean that particular feature is more helpful in predicting the outcome. I need to choose the 2 features that are most useful for prediction. To do that, I rank the features from highest score to lowest score and pick the top 2. After ranking the features by their mutual information scores, feature C scores 0.20, and feature A scores 0.15, have the highest scores, so I choose those 2. I'm working with a dataset containing 5 features. Let's call them A, B, C, D, and E, and a binary target variable. This means each data point has values for these 5 features, and a corresponding label indicating whether it belongs to one of 2 categories. I'll use the _mutual_info_classif function from the Sklearn library to figure out how strongly each of my 5 features relates to the target variable. Mutual information is a statistical measure that quantifies this relationship. Higher values mean a stronger relationship. Here are the results after running the mutual information calculation. Feature A has a score of 0.15, feature B has 0.02, feature C scores 0.20, feature D scores 0.08, and feature E scores 0.01. These numbers tell me how much information each feature provides about the target variable. I now rank the features in order from highest to lowest mutual information scores. This ranking shows the feature's importance in predicting the target variable, with higher ranked features being more useful. I arrange the features according to their scores. C 0.20, A 0.15, D 0.08, B 0.02, E 0.01. Feature C has the highest score and is therefore ranked highest, followed by A, and so on. I need to select the top 2 features from this list, based on their mutual information scores. These will be the features that best predict the target variable. I'll pick the top 2 features based on my ranking, which are C and A. These are the features providing the most information about the target variable in my dataset. And there you have it. The best 2 features, according to their mutual information scores, are C and A. These are the features I'll choose for my model. I have a dataset with 5 features, labeled A, B, C, D, and E. The target variable is binary, meaning it can only take on 2 values, like 0 or 1. This is the data I'll use for feature selection. This line describes the specific features in my dataset, A, B, C, D, E, and confirms the target is binary, 2 possible outcomes. We're selecting features based on how well they predict the target. I'm using the _mutual_info_classif function from the Sklearn library in Python to calculate how much information each feature provides about the target variable. It measures the statistical dependence between them. These are the mutual information scores generated by the _mutual_info_classif function. Each number represents how much information the corresponding feature provides about the outcome. A higher score means a stronger relationship with the target variable. I'm ranking the features from most to least informative based on their mutual information scores. The ranking helps me pick the best features for my prediction model. This is the ordered list of features, sorted from highest mutual information, C, with a score of 0.20, to lowest, E, with 0.01. I'm focusing on this order to select top features. I will select only the top 2 features from the ranked list. That is, the 2 features with the highest mutual information scores, since the goal is to get the most useful features. Based on the ranking, features C and A are the 2 features that provide the most information about the target variable and therefore the top 2 features I select. I have a dataset with 5 features, which I've labeled A, B, C, D, and E. Each feature is a variable describing something about the things I'm studying, and they could be numbers or categories. I also have a target variable, a binary outcome telling me whether something is true or false for each data point. Think of it like predicting if a customer will buy a product or not. The features are things like age, income, location, and the target variable is whether they bought the product. I'm using a tool from Sklearn, a popular Python library for machine learning, called mutual_info_classif. This tool helps me figure out how strongly each feature is related to my target variable. It gives me a score for each feature representing the strength of that relationship. Higher scores mean stronger relationships. The calculation itself is a bit mathematically complex, but the core idea is to see how much knowing the value of a feature helps you predict the target variable. These are the mutual information scores I got from using mutual_info_classif. For example, feature C has a score of 0.20, which is higher than the score for feature A, 0.15, and all the others, suggesting it has a stronger relationship with my target variable. Based on the scores, I need to choose the two features that are most informative about my target variable. I do this simply by sorting the features in order from highest score to lowest score and picking the top two. It's like choosing the two most helpful clues to solve a mystery. After sorting the features by their mutual information scores, features C and A have the highest scores, 0.20 and 0.15, so I selected them. These are the two features I would keep in my model because they are the best predictors of the binary outcome. I'm using mutual information to pick the best features from my dataset. It's like a detective looking for clues. The features with the strongest relationship to the outcome are the most important ones. I have a dataset with 5 features, A, B, C, D, and E, and a binary target, meaning there are only 2 possible outcomes, like yes, no or pass, fail. I'm trying to select the best features to predict the target. I'm using Sklearn, a popular Python library for machine learning, and specifically its mutual_info_classif function. This function calculates how much information each feature gives me about the target variable. Higher scores mean more information. These are the mutual information scores for each feature. For example, feature C has a score of 0.20, indicating a stronger relationship with the target than feature B, score of 0.02. The mutual information score measures the amount of information one variable reveals about another. A higher score suggests a stronger relationship. In simpler terms, how well does knowing the feature help me predict the target? I'm ranking the features from highest to lowest mutual information score. It's like sorting candies from most to least delicious. Here's the ranking. C is the best feature, then A, and so on. I need to choose only the top 2 best features. Based on the scores, C and A are the best 2 because they have the highest mutual information scores, making them the most informative for the task. I have a dataset with 5 features, which I label A, B, C, D, and E. The target variable is binary, meaning it only has 2 possible values, like 0 and 1. Think of it like classifying emails as spam, 1, or not spam, 0. I use Sklearn's mutualinfoclassif function to calculate how much information each feature gives me about the target variable. A higher score means a stronger relationship. This helps me select the most useful features. I get these scores. A equals 0.15, B equals 0.02, C equals 0.20, D equals 0.08, E equals 0.01. These numbers show how well each feature predicts the target. Feature C has the highest score, meaning it's the best predictor. My goal is to pick the 2 features with the highest mutual information scores to get the best prediction performance. I'm looking for the features that provide the most information about whether the target is 0 or 1. After ranking the features by their scores, C and A have the highest values, 0.20 and 0.15. Therefore, I select C and A as the top 2 features. I calculate how much information each feature gives me about the target variable. This helps me understand which features are most useful for predicting the target. I use a function called mutual_info_classif from the scikit-learn library to do this calculation. It's like figuring out how much one clue helps you solve a mystery. This is the specific function I use to do the calculation mentioned above. Scikit-learn is a popular Python library for machine learning. mutual_info_classif is a part of that library. I get a score for each feature, showing how strongly it's related to the target variable. A higher score means a stronger relationship. For example, feature C has a score of 0.20, which is higher than feature A's score of 0.15. That means C is better than A. Pretty cool, huh? I sort the features from best to worst based on their scores. The feature with the highest score is ranked first, the one with the second highest score is second, and so on. It's like ranking athletes by their scores. Highest scores go first. From the ranked list of features, I pick the top 2 features with the highest scores. These are the features I'll use for further analysis or model training because they show the strongest relationships to the target. This shows the features after I rank them. C has the highest score, 0.20, then A, 0.15, and so on. These are the top 2 features I selected from the ranked list. They provide the most information about the target variable based on the mutual information scores I calculated. These are the 5 features in my dataset I am going to use. Each feature is a variable that describes my data. Think of these features as 5 different pieces of information you have. This is what I'm trying to predict. A variable that only has 2 possible values, like 0 or 1, or yes or no.